Hi, good morning everyone. Welcome to SAHASRA tutorials. If you are watching this video first time, please subscribe the channel and press the bell icon for getting more videos. Okay, coming to the point, today we are going to learn the concept graph of a quadratic polynomial in the chapter polynomials of 10th class. This graph of a quadratic polynomial is very important problem for SSC board examinations also for 4 marks. So, my dear children, let us see how to draw the graph of a quadratic polynomial. Children, already we discussed in previous videos what is the graph of a quadratic polynomial. Let me know what is the graph of a quadratic polynomial. The graph of quadratic polynomial is parabola. So, how to draw the graph of quadratic polynomial? First, suppose if we have drawn a graph of a quadratic polynomial, what are the possibilities of that graph? So, if you draw a graph of the quadratic polynomial, it will intersect the x-axis at two distinct points. It will intersect the x-axis at two distinct points, or it will touches the x-axis at only one point. It will touches the x-axis at only one point. It will never touches the x-axis at any point. It will never touches the x-axis at any point. So how can we find the zeros of a quadratic polynomial through graph? Means if we draw the graph of a quadratic polynomial, the graph of a quadratic polynomial where the x-axis it touches, where the graph of a quadratic polynomial touches the x-axis, that points x-coordinates are called the zeros of the polynomial. So see here, first one is when we draw the graph of quadratic polynomial, it will intersect the x-axis at two distinct points. That means it intersects the x-axis, this is x-axis and y-axis. It will intersect the x-axis at two distinct points, so that these points x-coordinates are called the zeros. So that it will intersect the x-axis at two distinct points, hence it has two distinct zeros. Another one is, if draw the graph of quadratic polynomial, if the graph of the quadratic polynomial touches the x-axis at only one point, so that point is nothing but zero of the polynomial. Here it touches the x-axis at only one point. That means it has two equal zeros. We consider the two equal zeros as 1 0. Next, one more. If we draw the graph of a quadratic polynomial, it will never touches the x-axis. It will never touches the x-axis means it has no real zeros. These are the three possibilities when we have drawn the graph of a quadratic polynomial. So we have many quadratic polynomials. Among them, I consider one of the polynomial which is the type. We have so many polynomials. Among them, we consider one of the quadratic polynomial ax square plus bx plus c, which is the type where a is equal to 1 and x coefficient is nothing but b is equal to either plus 1 or minus 1. A is equal to 1, b is equal to plus 1 or minus 1. And here c is very important. C is equal to negative integer, which is the product of two consecutive integers, ignoring the sign. A is equal to 1, b is equal to either plus 1 or minus 1. C is equal to negative integer, which is the product of two consecutive integers, ignoring the sign. So, take this type of quadratic polynomial. Let us see how to find the zeros of a quadratic polynomial. How to find the zeros of the quadratic polynomial? By factorization method, we can find the zeros of a quadratic polynomial that we discussed in previous videos. Let us see particularly this type of quadratic polynomial. How can we find the zeros? Very easy. Without factorization method, we can find easily this type of zeros of this type of quadratic polynomial. See here. I want to consider the quadratic polynomial a is equal to 1, b is equal to plus or minus 1, c is equal to negative integer, which is the product of two consecutive integers, ignoring the sign. Okay. So leave model 2. See only model 1. Here x square coefficient is 1, x coefficient is minus 1, minus 6 is the negative integer, which is the type. Like that here also. This one also. Here x square coefficient 1, x coefficient is either plus 1 or minus 1, plus 1. minus 6, which is the negative integer. That's the type of this type of polynomials. Okay. Without factorization method, how can we find the zeros of this quadratic polynomial? It is very simple. See here 6, 12, 42, 72. These are the numbers which are the product of two consecutive numbers. 6 can be written as 2 into 3. 12 can be written as 3 into 4. 42 can be written as 6 into 7. 72 can be written as 8 into 9. First you have to write that one. 2 comma 3. 12 can be written as 3 comma 4. And 42 can be written as 6 into 7. 72 can be written as 8 into 9. These are not the zeros of these quadratic polynomials. Which are the zeros of this quadratic polynomial? Means simply whatever the sign we have here, x coefficient, whatever the sign we have for x coefficient, that sign keep for smaller number, and that opposite sign keep for bigger number, larger number. So minus 2 plus 3. Minus 2 comma plus 3 are the zeros of this quadratic polynomial. Once we have to verify by factorization method, then compulsory we will get minus 2 and 3 are the zeros of this quadratic polynomial. Minus 3 plus 4, minus 6 plus 7, minus 8 plus 9. Which are the zeros of these quadratic polynomials respectively. Okay. Here also, again I am saying this one. First you have to write 6 as product of two consecutive integers. 6 is equal to 2 into 3. 6 is equal to 2 into 3. 2, 3. So these are not 2 and 3 are not zeros of the quadratic polynomial. Again I am explaining whatever the sign we have for x, that sign keep for smaller number. That opposite sign, my negative opposite sign is positive. That sign keep for larger number. Minus 2 plus 3. Here minus 3 plus 4. Minus 6 plus 7. Minus 8 plus 9. Like that. Similarly here also. 6 can be written as 2 into 3 again. Right. 2 into 3 minus 12. That means 12. 3 into 4. 42. 6 into 7. 8 into 9. Okay. So these are not the actual zeros of this quadratic polynomial. What are the zeros? Whatever the sign we have here, that sign keep for smaller number. X has the sign plus here, so that I have to keep plus here. Opposite side minus. So plus minus, plus minus, plus minus. So plus 2 minus 3 are the zeros of x square plus 6 plus x minus 6. Plus 3 minus 4 are the zeros of x square plus x minus 12. Like that. Again I am telling ax square plus bx plus c, which is the quadratic polynomial. If we consider particular type, that is, if a is equal to 1, b is equal to plus or minus 1, c is equal to negative integer, which is the product of two consecutive integers, ignoring the sign, leave the sign. Only 6 can be written, that number can be written as product of two consecutive integers, like 6 can be written as 2 into 3, 12 can be written as 3 into 4. So what are the actual zeros? It is very simple. First write 6 as 2 into 3. Whatever the sign we have for x, that sign keep for the smaller number. That opposite sign for larger number. Like that, these are. Which are the zeros of particular type of these quadratic polynomials. And one more point. These two problems we have in 10th standard are very, very important problems that I will explain now. And one more thing, coming to model 2. So here it is the type a is equal to x square coefficient is equal to 1, b, that means x coefficient is equal to either plus 1 or minus 1, and c is, see here, plus 6 plus 12 plus 42 plus 72, like that. C is positive integer. C is positive integer, and which is the product of two consecutive positive integers. Means 6 can be written as 2 into 3. 2 and 3 are the positive integers and which are consecutive. Now 42 can be written as 6 into 7. 12 can be written as 3 into 4, like that. So here in this model 1, particularly this type, we have the zeros, but here we don't get the real zeros, because by drawing the graph of this quadratic polynomial, it will never touches the x-axis at any point, so that these type of polynomials has no real zeros. How can we verify? Before drawing the graph of a quadratic polynomial means find the discriminant of this quadratic polynomial first. Discriminant is nothing but delta is equal to b square minus 4ac. If it is less than 0, then it has no real zeros. Then it has no real zeros. So let us consider x square plus x plus 6. It is the polynomial. What is the value of a here? 1. What is the value of b? X coefficient nothing but plus 1, nothing but 1. What is the value of c? 6. If it is less than 0, then the graph of the quadratic polynomial never touches the x-axis at any point, so that it has no real zeros. See, 1 square minus 4 into, what is the value of a? 1. What is the value of c? 6. So 1 square is 1, 4 into 6, 24. 1 minus 24 is nothing but minus 23. Minus 23 is always less than 0. Here we got that delta is less than 0. Hence, the graph of this quadratic polynomial does not touch the x-axis at any point, so that it has no real zeros. Verify for this one also. I want to take x square minus x plus 12. For a is equal to 1, b is equal to minus 1, c is equal to 12. Verify this. For this also we will get a delta less than 0. See, b square means minus 1 whole square minus 4 into, what is the value of a? 1. What is the value of c? 12. 1 minus 1 whole square nothing but 1. 4 into 12, 48. 1 minus 48 minus 47. It is less than 0. So, particularly if we consider this type of polynomials that are a is equal to 1, b is equal to either plus 1 or minus 1, and c is the positive integer, which is the product of two consecutive positive integers, then the type of quadratic polynomials has no real zeros. So, this has no real zeros. For this also, this also has no real zeros. So here I consider only one polynomial, and in two models I explained clearly. So this type of polynomials has real zeros which are distinct, and this type of polynomials has no real zeros. Now we can discuss the graph of this one, x square minus x minus 6. How to draw the graph of that polynomial? We can discuss. Okay. So this question they will give like this: draw the graph of the quadratic polynomial x square minus x minus 6 and find the zeros and justify your answer. Like that they will ask the question. So let us see how to draw the graph of this quadratic polynomial. So for drawing the graph we need x coordinate and y coordinate. So that I want to consider this polynomial x square minus x minus 6 as y. That means that y is equal to x square minus x minus 6. For drawing the graph we need some steps. That are, first one is table and second one is steps to draw the graph. Third one is verification and fourth one is conclusion. By last one on the graph paper we have to draw the graph. By these steps we can complete the graph of a quadratic polynomial. So first how to draw the table, let us see. So here x square minus x minus 6. First we have to find the zeros of this quadratic polynomial. Okay, what are the zeros of this quadratic polynomial? So already we taught x square minus x minus 6. So 6 can be written as product of two numbers 2 and 3. What are the zeros? Simply we can say whatever the coefficient we have for x, that how to keep for minus smaller number, and the opposite sign for larger number. The opposite sign for larger number. So minus 2 and 3 are the zeros of this quadratic polynomial x square minus x minus 6. So simply we have to write first the two zeros, minus 2 and 3. Minus 2 and 3. These are the zeros of this quadratic polynomial. Let us consider that values are x. So now what are the values we have to take for x? Simply how to take one value, one integer before minus 2 and one integer after 3, and the integers between minus 2 and 3, that are minus 1, 0, 1, 2. These are the values we have to take for x. Again I am repeating this. X square minus x minus 6. First we have to calculate the zeros of that polynomial, that are nothing but minus 2 and 3, minus 2 and 3. How to take one integer before minus 2 and one integer after 3 and the integers between minus 2 and 3. These are the values of x. Now we have to calculate the y values. Already we know minus 2 is the 0 of this polynomial. By substituting in place of x as minus 2, then surely we will get 0. Similarly for 3 also. Now substitute in place of x as minus 3. So then we get y is equal to minus 3 whole square minus of minus 3 minus 6. Minus 3 whole square is nothing but 9 plus minus plus 3 minus 6. 9 plus 3 12. 12 minus 6 6 6 minus 3 6. So no need to calculate again the value of y at x equal to 4. Simply we can write 6. See, it is correct or not once we have to check. Remaining we can write directly. Y is equal to 4. 4 square minus in place of x 4 minus 6. 4 square means 16. Minus 4 minus 6 nothing but minus 10. 16 minus 10 6. Directly we get 6. Now calculate y value at x equal to minus 1. Minus 1 whole square minus of minus 1 minus 6. Minus 1 whole square is nothing but plus 1. Minus into minus plus into 1 1 minus 6. 1 plus 1 2. 2 minus 6 minus 4. The value of y at x equal to minus 1 is minus 4. Similarly at x is equal to also minus 4. No need to calculate again. At x equal to 0. Y value at x equal to 0. So 0 square minus 0 minus 6. Nothing but minus 6 minus 6. At x equal to 1 also minus 6. These are the y values with respect to x values. So therefore the coordinates are minus 3 comma 6. These are the points. Minus 3 comma 6. Minus 2 comma 0. Minus 1 comma minus 4. 0 comma minus 6. 1 comma minus 6. 2 comma minus 4. 3 comma 0. And last one is 4 comma 6. These are the points enough to draw the graph of the polynomial. If you want to take more values also no problem, but these are the values enough for that. So next, how to draw the graph? So for drawing the, we need some steps. That are steps to draw the graph. First, these are the points. Plot the points on the graph paper. This is the graph paper. Before plotting the points, this scale is very important. So scale on x-axis I have taken 1 cm. This is 1 cm. That length 1 cm is equal to 1/8. On y-axis 1 cm equal to 1/8. On x-axis 1 cm equal to 1/8. On y-axis 1 cm equal to 1/8. So compulsory we have to write the scale on the graph paper with pencil. Okay. So first point is plot the points on the graph paper. Now I want to plot out these points. Minus 3 comma 6. It is the first point. So this is x coordinate and this is y coordinate. X coordinate we have to take on x axis, y coordinate and we have to take on y axis. Then intersecting point we have to write it. So minus 3 on x axis, 6 on y axis. So here minus 3 and 6. Here it will come. The position of that is minus 3 comma 6. And the second point is minus 2 comma 0. And minus 2 comma 0. So this is minus 2 comma 0. Third point, minus 1 comma minus 4. On x axis minus 1, y axis minus 4. This is the point. Minus 1 comma minus 4. And next one is 0 comma minus 6. On x axis 0, y axis minus 6. And 1 comma minus 6. On x axis 1, y axis minus 6. This is the point. So it is minus 1 comma minus 4. And which is 0 comma minus 6. It is 1 comma minus 6 and 2 comma minus 4. X axis 2, y axis minus 4. This is the point which is in fourth quadrant. 2 comma minus 4. 2 comma minus 4. And next one is 3 comma 0. This is the point. 3 comma 0. Next one is 4 comma 6. 4 comma 6. Here we get the point. 4 comma 6. Now join. So plot the points on the graph paper. Next one is and join them with the free hand. Join them with the free hand. I want to join these points. Join the points with the free hand. like this. So keep arrow marks because it will extend it. So first plot the points on the graph paper and join them with a free hand. Then it represents what? It is the shape of parabola. Then it represents a parabola. Second, what we have to observe? We observe that this parabola intersects the x-axis at minus 2 comma 0 and 3 comma 0. This parabola intersects x-axis at minus 2 comma 0 and 3 comma 0. Already we discussed where the graph of the polynomial intersects the x-axis, that points x coordinates are called the zeros of the polynomial. So that minus 2 and 3, therefore minus 2 and 3 are the zeros of this quadratic polynomial. So here second point is we observe that the parabola intersects the x-axis at minus 2 comma 0 and 3 comma 0. Therefore which are the zeros? Therefore the zeros of the given quadratic polynomial are minus 2 and 3. Minus 2 and 3. Next, we need to verify these minus 2 and 3. This is through graph, these are the zeros. By actual calculation, these minus 2 and 3 are the zeros or not, we have to verify. So let us consider the polynomial. Let p of x is equal to x square minus x minus 6. So put x is equal to minus 2. If we get p of minus 2 equal to 0, then we say that minus 2 is the zero of the polynomial, right? So p of minus 2 is equal to minus 2 whole square minus of minus 2 minus 6. Minus 2 whole square is nothing but 4. Minus 2 minus plus 2 minus 6, that is equal to what? 4 plus 2 6, 6 minus 6 0. Next put x is equal to 3. Another one is 3. Put x equal to 3. Therefore p of 3 is equal to 3 square minus 3 minus 6. 3 square means 9. Minus 3 minus 6 minus 9, that equal to 0. So clearly we got p of minus 2 equal to 0 and p of 3 is equal to 0. Hence we say that minus 2 and 3 are the zeros of the polynomial. Next, conclusion. Conclusion we have to write nothing but what are the zeros? That is nothing but solution set. So conclusion we have to write solution set is equal to set of minus 2 comma 3. These are the zeros. So it is the graph of the polynomial y is equal to x square minus x minus 6. Compulsory we have to mention that y is equal to x square minus x minus 6. This is the graph of the quadratic polynomial. Again I am repeating what are the points we require. First point is table. Next one is steps to draw the graph. Third one is verification. Fourth one is conclusion. On graph paper we have to draw the graph. In the graph paper the most important points are scale. So on x-axis 1 cm equal 90. You can take, that is your wish. 1 cm equal 2 8 3 8 like that. I have taken here 1 cm equal 1 8 and y-axis 1 cm equal to 1 unit. So by plotting these points, this graph intersects x-axis at 2 distinct points. Otherwise for some polynomials it will touches the x-axis at only 1 point. Or some problems, some quadratic polynomial, it will never touches the x-axis. So these are the steps we have to draw. And for this polynomial, we have to mention these arrow marks, and compulsory we have to mention this which quadratic polynomial is this. Y is equal to x square minus 6 minus 6. This is the graph of a quadratic polynomial. So I hope you will understand this graph, how to draw the graph of quadratic polynomial clearly. Thanks for watching.